Hey guys, welcome back. Let's see today's questions. Let's start with the lead food. Okay, let's open this. The earliest finish time for land and water rights. Okay. We have two categories of theme park attractions. Okay, land rides and water rides. Land start time and their duration. Okay, earliest time the highest land ride can be boarded. Okay. And how long the ride lasts. Then again, we have start time of this particular, water ride and the duration. The tourist must experience exactly one ride from each category in either order. A ride may be started at its opening time or any later moment. If the ride started at time t, it finishes at time t plus duration. Immediately after finishing one ride, the tourist may board the other. Okay, if it's already open, or wait until it open. Okay, return the earliest possible time at which the tourist can finish both. And here is the examples. We have start time, end time, and okay, this is land start time to 8 and their end times, last duration. We have this start time and end time. Okay, so if we start at what is the explanation, let's say plan A, ride 0, and then water ride 0, land ride 0 meaning 2 to 4, and then 6 to, not 2 to 4 but 2 2 to 2 plus 4, then uh, it becomes 6, right? Then 6 to 6 plus 3. Uh, so here you can see 2 and then it finishes at 6, and we can start at 6 and finish at 9. We have plan B that start at 6 and it ends at 9, right? And okay, land ride 1 opens at 8 and you know start at 8, start at time 9, finishes 9 plus the duration. Okay, we have plan C. First land ride 1, uh, start at 8, finishes at 9, and then uh, water ride starts at 9 and finishes at 12. Okay, and we are earliest possible finish time is 9. And this is our answer. Okay. So meaning that we can it's not like if this is starting at particular time, then if we try other ride, and we can come to later and adjust the start time, you know and yes, something like this. So we need exactly one ride from each category. Okay, so we can choose, okay, the ride which has low duration. Okay, so uh okay, so it's always good to start early in order to finish early, right? So we can what we can do now. Okay, uh we need also the planned duration low. Okay, and okay, we need to start time early and the land duration uh as low as possible. Okay, and similar for water start time. Okay, what is the constraints? 100. Okay, so first, as a brute force, we can check, uh, you know, let me see, start time and end time. Uh, we can have like something and land. First, let's get the, okay, and land duration. So start time of this. Okay, we can have uh, new in uh, and where we store the start time and the duration. Uh, land, water. Okay, we have in and again two. Let's try to put things is less than n plus I, and for land, let's put uh land of I of 0 will be land start time. Okay, and similar at 1 we will have the land duration. Okay, now similar in I is equal to sigma I is less than n plus I, and we need water of I 0 will be water start time. Again, uh, at 1 we need its duration, right? So, and we need earliest possible time at which tourist can finish board, meaning that earliest finish. Okay, Let's put into the and we need to sort both arrays dot sort first land where we will be sorting according to the start time. Okay. Uh, Return a of 0 minus b of 0. But what if both are same? A of 0, b of 0. Then whoever's duration is smaller, okay, according to b of 1 minus b of 1. Great. And similar work for water also. Uh, water. Okay. Now let's start our name. Let's put uh, a land or water. What to put? Let's go with the land. Okay. Uh, and that's good. First from land and uh, we'll have the start time, right? First zero. Then we have end time. First of one. Okay. Uh, End time will be start time plus first. Okay. Meaning this one is the duration, right? And for this one, in let's start second water. Here we have uh, water, you know, start time, uh, second of zero, and we have in water and time we this start time plus second of one. Okay. Now we have to check if end time. Okay. Mm, okay. Uh, Whoever start time is, let's say, if this is his start time is less than this particular start time, meaning we have to first watch this land ride, then water ride, right? So in that case, what you can do is uh, end time of this, right? The earliest finish time will be map dot min of uh, earliest finish time and calculate the finish time of this particular case. We have this end time where this particular stuff is ending, right? And and what we have uh, end time minus the water start time. Okay, uh, water start time. This is the gap between this particular start time, end time, and this start time. The gap. Okay, and we can think like this, right? Mm, we can put math dot absolute whatever the gap we have in between, that we have to wait, right? And plus the uh, you know plus the, I guess, duration itself, right? This duration itself that we need. So the finish time will be this block. Okay. And else, meaning we have uh, water start time early. Okay. In that case, what will be our finish time? Mm, so I guess in both cases this will work, right? Again, this finish time, uh, this finish time is basically how much time it takes after completing the land ride, right? But we need to add the duration of land ride also, right? I guess we need only finish time. So uh, this is the start time of water. Uh, okay. If the water ride is early, okay, in that case, start time and whatever the end time we have, whatever the gap we have that we need to wait, and again we need end time. Uh, okay. Uh, yeah, little bit confusion. Now this is the uh, let's say land start time, land end time, right? And yes, okay. Uh, you'll be able to check that the last finish time, right? This last end time, this last water end time, water end time. Mm, So we actually have its put duration itself. Actually, we have this variable already. Okay. Land um, s- start time, let's say land duration. Okay. And we have water start time and the water duration. Now what we need is earliest finish time. So if this is starting before the water time, okay, then meaning we have, if uh, meaning we can perform this, right? But we can check both in one, if we start this early or this early. Okay. Let's say if we start the land start time early, then this ends at this particular duration, right? We need to remove this. This ends after this duration. So let's put it like In L start time plus L duration. Okay, meaning we completed the water lab and then we can start this particular one. Okay, so and finish and time. Okay, and we have to just check. Okay, uh, if finish land time is greater than water start time, then what you can do is finish land time plus this particular duration. Okay, that you can do. Else, uh, else what you can do? Finish land time. Now, meaning that we have to wait to start the water time, right? So in that case, what to do? In that case, I guess you can simply do uh, finish time uh, plus equal to EPS. Uh, water start time minus this finish time. Okay, that you can do. And let's do this one early. Okay, and later on you can add the duration. Okay, and now we have the finish time according to if we start the land first. Let's go to then finish time. Okay. Now, uh, if we finish this water first? Uh, which water time. Okay. So we have the water start time plus water duration. Okay. Again, if water finish time is lesser than this start time, then we need to add the waiting time. Actually, we don't need ABS. Okay. And here also we don't need ABS. Now, what next? Now, water finish time plus equal to land duration. Now, again, we have to check with the water duration time. Okay. And I guess at last result, I've just finished time. Uh, and start. I'll start. Okay. It's let's try to submit. Okay, it's accepted. Uh, you can you know do early stop and try to improve it. Okay. Let's see the next one. Uh, which projects? Okay. Given an integer and a number k, the task is to find the maximum pair sum with the following conditions on the pair. Pair difference should be at least a, pair should be disjoint. Pair should be disjoint. For example, if x y is a result pair, then neither x nor y should appear in the any other result pairs. Some of the pairs, some of the p pair means the sum of two p elements in the set. If no valid, okay. We have k four disjoint sets pairs less than k. Three, three, five, and 10, 12, then 15 and 17. Difference should be less than k. Okay. First we have 3, 5, then 10, 15, no, 10, 12, right? So if we sort this, then it would be easy to pick up, right? For example, if we sort this, then 5, 10 come first, then we have this only. Let's try array sort, and let's say array about like for I is less than sorry, and plus I, then uh, if we have only one element, then what to do? We cannot form pair. If n is equal to 1, then become -0 because we don't have anything. Okay. And now we have at least two things to mm, what you can say. Okay, also we need the sum of them, right? So in let's have some 0 and if I minus I plus 1 minus we can go with the last element. Okay. If it's less than k, k less than k, then this is the valid case. Then you can add the sum plus equal to I plus 1, then sum plus equal to AR of I. Okay. And since this is valid, you have to go for uh, I plus equal to 1. And otherwise, you have to go the next one. Okay. And Once you have this sum, then make sure uh, no disjoint. Okay. What if it contains duplicates? Let's try one example. We have to return it the sum. Okay. So we have to return the sum. Uh, we have 3 4s. 3 plus 5. Because 5 minus 3. Okay. Let me copy this one and try to analyze. So first we are sorting it to get the good pairs, right? So let's say 3, 5, 9, 12, sorry, 10, 12, 15, and 17. We pair this one, then it becomes 80. This sum, okay? Now we pair this one, which becomes 19. Okay. Now we pair this one, which becomes 15, 27. Now we are here, and this is our answer. So let me see. These are the pairs. Okay. 3, 5, 10, 12, and 15 and 17. Okay. We need maximum pairs. Okay. Uh, we need a maximum pairs. In that case, we have to make sure we are whenever we're trying to form the pairs, we need the max difference between them to get the maximum results, right? Uh, if we start from the last one, let's say we have 17 and 15, then uh, 10 and 12, then we cannot form, then again go to the next. Okay, if we start from the last, then might work. Greater than 0 minus 1 plus. And we need minus. Okay. Now we have 68. Actually, this one is the greater one. So this should be greater. Now we have answer. Uh, okay. Now what if we have duplicates? Let's say if we have uh, mm, if we contain duplicates, what to happen? Then we need to let's try submit. Check later. Okay, it's working. Thank you. I guess it's done today's stuff. So yeah, thank you for watching.